Semiconductor overview definition. A semiconductor is a material that has electrical conductivity between that of a conductor and an insulator. Semiconductors are crucial in modern electronics, enabling the creation of transistors, diodes, and other electronic components. Types of semiconductors. 1. Intrinsic semiconductors. Definition: pure semiconductors without any significant impurities. Common materials: silicon, Si, germanium, Ge. Properties: at absolute zero, they behave like insulators. As temperature increases, electrons gain energy and can move, allowing conduction. 2. Extrinsic semiconductors. Definition: semiconductors that have been doped with impurities to improve conductivity. Types: N-type semiconductors, doped with elements that have more electrons than the semiconductor, e.g., phosphorus in silicon. The extra electrons provide more charge carriers, negative. P-type semiconductors, doped with elements that have fewer electrons than the semiconductor, e.g., boron in silicon. The absence of electrons, called holes, acts as positive charge carriers. Formation of semiconductors. 1. Crystal structure formation. Silicon crystals. Silicon atoms are arranged in a tetrahedral lattice. Each silicon atom shares electrons with 4 neighboring atoms, forming covalent bonds. This structure makes pure silicon an intrinsic semiconductor. 2. Doping process. N-type doping. When silicon is doped with a pentavalent element like phosphorus, which has 5 valence electrons, the extra electron becomes available for conduction. P-type doping. When silicon is doped with a trivalent element like boron, which has 3 valence electrons, a hole is created, where an electron could go. This hole can move through the lattice, facilitating conduction. Applications of semiconductors. Diodes. Combining N-type and P-type semiconductors creates a p-n junction, essential for diodes. Transistors. Transistors, which form the backbone of digital circuits, rely on semiconductors to switch and amplify electrical signals. Integrated circuits, ICs are built from millions of transistors and are used in nearly all modern electronic devices. Conclusion: semiconductors are a foundational technology in modern electronics, and their ability to be engineered through doping is what enables the functionality of everything from smartphones to solar panels.